Good morning. Today we are going to see the topic is assembly line balancing. So first of all we are going to see the assembly line balancing. So we are needed to know the what is meant by automations. So automation is nothing but the machine is substitution of the employee like a robot. So this is automation. So this topic is covered in unit 1 and low cost automation. So first what is meant by assembly line balancing. If people are going to manufacturing components means every components every some products having some number of components available. So before going to manufacturing of the component, so we are needed to ensure the correct line balancing. So why we go for line balancing means if you correct line balancing is increase the production rate, so the profit will be increased as per our planning. So there are some methods in assembly line balancing. This is a assembly analysis and assembly chart. If you are going to prefer the assembly chart means we are needed to done the assembly analysis is a very important thing. So assembly analysis is nothing but how many components available, so based on how many operations available, so how many component each and every components having how many minutes taken for operations. So these are the things assembly analysis. So this is a simple examples. There are several methods is available while line balancing algorithm. So in this sections we are going to see the one or two methods. So before going to the method of a line balancing algorithm, we will be see the simple examples. So here the some one examples given. So what about that example is we are going to manufacturing the electrical appliance. This is the appliance. So you are needed to done assembly line algorithm. So annual demand is 1 lakh units per year. So 50 weeks per year, 5 shift for week and 7.5 hours per shift. The manual leveling will be 1 worker per station. So if the what is mean by the manning level means there are more than 1 worker in work station is manning level. So here the manning level is only 1 work per station is available. Then obtain the efficiency is up to 96%. Then the repositioning time cost per cycle is 0.08 minute. Now we are going to calculate the total work content time. So this is ran to TWC, then required hourly production orders RP to achieve the annual demand. So C is cycle time and then E equal to service time. So these are the things we are going to calculate. See, this is the descriptions, like there are in this single model assembly lines there are 12 amperation is available if you are needed to complete the full product. Okay, so each and every serial numbers having some standard set of operation available. Then at that operations there are some special machine is needed to complete the work. So here the third column is given the time for the time taken for the particular operations. These timings definitely needed to complete this the particular operations. Okay, the last line is shows the preceded. So sir, what is mean by preceded? So one thing is we maybe give some examples, like if we are going to traveling from Tirchi to Chennai in by the train. By the train means which one is possible after reaching of Viluppuram only we are needed to reach the Chennai. So the simultaneously here the operation done by, if you are needed to complete the third operations means we are needed to complete the first operation. So if you go to touch the fourth operation means we are needed to complete the first two things. So this precedent is nothing but unable to done the fourth operation without the first two operations for. Okay, so this is the precedent. Based on that precedent we are needed to draw the drawing. Based on the drawing we will be we will implement the line balancing algorithm, right? So here the serial number 1 to 12 is available. So this is the first one is place frame in a work holder and a clamp. So operation number 2 is assemble plug, and third is assemble worker. Number 4 mentioning the wire power guard to motor. Then the number 5 is wire power guard to switch. Then sixth operation is assembly mechanisms blade to brackets. So 7 is assemble blades to brackets. Then 8 operation is assemble motor to brackets. 9 is airline blade and attach the motors. 10 assemble switch the motor brackets. 11 turns to the cover and inspect the test. Then 12 is place the door pan packing. So this is the assembly line diagram. This is this diagram drawn based on that precedent. See, this diagram clearly shows the before going to start the first and second operation, we need not to complete any other operations. Okay, if you needed to complete, if you needed to start third operation, means need to complete the first operation. Then you have consider is fourth operation need to start, means we are needed to complete the first, second and operation. Okay, so if you need to start the fifth operation, means the second operation need to complete fully. Okay, simultaneously we go for the sixth operation. So sixth operation need to start, means you are needed to start 1 and 3 simultaneously. The seventh operation means 1 and 3. So eighth operation is 1 and 3. Okay, so simultaneously on the 9 and 10 and 11 operation. These are the precedent diagram. So based on the precedent diagram, the given data, we are needed to find out the production rates and other things. Okay, so this is a analysis of single model analysis. This is solutions. Total work content time is 4 minutes. The production rate is calculated by the formula like the demand and there is a shift timing and 53.33 units per hour. Then we are going to calculate the cycle time. The cycle time is having some set of formulas. We substitute directly to this formula. The cycle time is 1.08 minute. So next thing is theoretical minimum number of workers given by. So how to calculate the theoretical workers required? This is a TWC divided by TC. This is 3.7. So approximately 4 workers required. Then the average service time against which the line must be balanced. So TS equal to TC minus TR equal to 1.08 minus 0.08. This is approximately is 1 minute. Okay, this is the objective is in the line balancing is distribute the total workload we are needed to calculate. So this is some condition is given, minimize and minimize. So now we are going to see the 3 algorithm, line balancing algorithm is available. So one is the largest candidate rule, the second is the Gilbridge and West method. So third one is rank positional weightage. Now in this sections we are going to see the large candidate rule. See, this is a large candidate rules, some of the steps available. If you are going to implement it in this algorithm, means there are some set of rules are available. So you are needed to follow this rules by the largest candidate rule. The first step is based on that timing we will be arrange the descending order. Okay, then we will be arrange the cycle time. Based on the cycle time we will be give the some text drawing. So see this is a given example. So based on the example we are implemented the largest candidate tool. So what means the timing will be arranged and descending order. Okay, so descending order like this that here the operation number is changed as per the timing. As per the timing the precedent order also changed. Then the solution is line efficiency, the TWC here divided by W by TS 4.0 divided by 5 1.8. So based on this formula we calculated the balance efficiency. So this is largest candidate rule. Here based on that largest candidate rule we framed some work. So however based on that the descending order so we framed the work element. So for example, the operations 2, 5, 1, 4, 3, 6, 8, 10, 7, 9, 11, like this we arranged the work element. So the third column shows the timing. The timing is descending order. We calculate the cycle time. So the last column is shows the cycle time. So as per the calculation, the cycle time is not more than 1 minute. So we couple the based on that cycle time, we couple three operations, or the two operations coupled by one station. Okay, on this station we have to perform some operations. Okay, so if not obtaining the cycle time 1 minute means we may be choose another station also. This figure showing the 5 station is separated out of the 12 operations, and the 12 operations having a separate minutes is available. Based on that the station time we will be executed this station. Okay, this figure showing is nothing but the 12 operations is available. So the 12 operations timing is mentioned. Okay, here the we are mentioning some of the stations. So each and every stations mentioning in some one color. Based on that cycle time, the preceded diagram is drawn as different colors as different stations like the, and 12 operation is covered in the 5 stations. Okay, so this figure showing the we have the 12 operations available. So we have splitted the 5 stations. This figure shows the workflow diagram. So first stations having 2, 5, 1 operation, the second station having 3, 6 operation, the third station 3 showing the 8, 10 operation, then station 4 having 7, 9, then the station 5 shows the 11, 12. So these stations and these operations are splitted by the largest candidate role. Okay, next section we will see the next thing.